In this video, we will be solving equations involving indices by reducing it to a linear equation. Let's recap what you have learnt about the addition of terms in index forms. Can you recall that these are like terms? Just like the algebraic terms 7y and y. So, we can simplify by adding these terms together, just like 7y plus y equals 8y. Thus, the expression is just 8 times 3 to the power of x. In other words, we substitute the common index form 3 to the power of x as y to reduce it to a linear expression before simplifying it. When solving equations involving indices, we can make use of this method to help us solve the equation. Now, it's time to take a look at how to solve an equation like this. First, look at the terms on the left side. Can you identify the common index form? Yes, 5 to the power of x is the common index form. This means that we can substitute the common index form 5 to the power of x as y, and the equation can be reduced to a linear equation. That is 3y plus y equals 500. Thus, we can solve for y to be 125. Now, are we done? No! Remember that we are solving for x and not y. So, let's replace y with 5 to the power of x and express 125 as 5 cubed. Now, the bases are the same, and we can compare the indices to get x equals 3. Next, let's look at a similar example. Again, can you identify the common index form? Yes, 2 to the power of x is the common index form. So, we can substitute the common index form 2 to the power of x as y, and we get the linear equation 8y minus 3y equals 80. We solve for y to be 16, and now it's time to solve for x. Like in the previous example, we replace y with 2 to the power of x and express 16 as 2 to the power of 4. Now, the bases are the same, and we can compare the indices to get x equals 4. Finally, let's look at this example. Can you identify the common index form in these terms? Well, it may not be as obvious. Let's express 2 to the power of x plus 2 in another form to help us identify the common index form. Using this law of indices, we can express 2 to the power of x plus 2 as a product of index forms, which is 2 to the power of x times 2 squared. And we know 2 squared is 4. Again, we should write the constant on the left-hand side of the term. So, 2 to the power of x plus 2 is the same as 4 times 2 to the power of x. Let's replace 2 to the power of x plus 2 with 4 times 2 to the power of x. Now, can you see that 2 to the power of x is the common index form? Like before, we can substitute the common index form 2 to the power of x as y, and we get the linear equation 4y plus 3y equals 224. Similarly, we solve for y to be 32. Again, remember that we need to solve for x. So, we replace y with 2 to the power of x and express 32 as 2 to the power of 5. Now, the bases are the same, and we can compare the indices to get x equals 5. In general, when solving equations involving indices by reducing to a linear equation, first, we identify the common index form and reduce to a linear equation by substitution. Then, we find the value of the substituted variable and replace it back with the common index form. Next, we express the constant as a product of prime factors so as to compare the indices to find the unknown in the equation.